I'll start recording now. So, hello and welcome to the NFDI talk. My name is Kurt Wilges and I work in the NFDI Association's office in Karlsruhe. In our NFDI talks, which take place every 2 weeks, scientists, researchers from different disciplines present exciting topics about research data infrastructure and research data management. All talks are live streamed and saved on our YouTube channel. After the talk, we invite you to ask questions and to discuss the topics. This interactive part, then the question and answers part, will not be recorded. In today's talk, Tobias Hamann will present a framework for research data management that includes a guided process to integrate research data management into researchers' daily lives. Welcome, Tobias. We look forward to your presentation.
Thanks a lot, Kurt. So today I would like to talk about my dissertation, and this dissertation is part of the NFDI for ING, which I am also part of. I currently work at the WZL with Professor Robert Schmidt, who is not only my supervisor for my dissertation, but also the spokesperson of NFDI for ING. And to give you a little impression where I'm coming from with my thoughts, last week we had the all-hands meeting with the NFDI for ING, and there I'm still under many different impressions. And I had a very interesting talk there about the idea why we do research data management. So the first and most obvious idea was that maybe the whole research data management is there to make data reusable, which is obviously our main goal. But also you could think a little bit further about research data management being a tool to make or to achieve new findings or like ideas from research data that already exists. And building upon that, and obviously from some years ago, I started thinking about that whole topic when I started the dissertation. I thought about what could we do to emphasize on that. So obviously there are the FAIR principles, but they are a tool rather than the one way to go. And obviously they are pretty good and most often cited tool that exists in research data management. But there are also like some limitations to the usability of that. And this is where I got into research data management a little bit more and in a little bit more into detail. How can we give researchers a little bit of different tool set that is maybe more applicable and more integratable into their everyday research? And we thought about that at the WZL quite a lot and did in the task area Frank of NFDI for ING some surveys and some workshops to figure out what exactly is the pain of the researchers. And well, the problem is that RDM can be overwhelming, not only for rookies, but also for experts. There are a lot of different requirements that you need to fulfill depending on your way of researching, the circumstances under which you are researching, your university, your funding organization, and maybe even your own professor. And there are different tools to guide you through this process, to support you. But there are also many different tools for the very same task you have to fulfill. And depending on which way you go with your research, maybe depending on your discipline, there might be different repositories more suitable than others. You have a vast majority of options to choose from, and this can also be overwhelming. Also, many researchers told us that they had a problem with the idea where to start even. Where do I start my research data management? How to begin? What does good research data management look like? And how does this relate to my research? And we also asked them about their common practices that are like already research data management in some ways. Some use Git already or something like that. And we looked at the research data management cycle, and we figured that there is like different tasks in there which have, let's say, a little bit unbalanced to them on how good research are at completing these tasks. So researchers are very good at this bottom half of the circle. So they know how to produce data, they know how to analyze it, and they also know how to store it so that they can reuse it themselves. So in their very own research project. And this is what they excel at and what they do on an everyday basis already. But this upper half there, that's usually not quite their strength. So we thought about what can we do in the NFDI for Ing within the task area Frank to enhance this. And I also thought about, well, what are the key problems there? And based on that, I started my dissertation in 2021 at the WZL. And I take you through the journey I went through as well, and which ideas I have, which research questions I would like to propose, and I would like to answer as well, hopefully. So the idea is that there is not one problem in particular that causes this lack of application of research data management or the problems researchers face when applying research data management, but a multitude of those. And for my dissertation, I've chosen to not look at the side of external factors from, for example, incentivation point of view, but rather reducing the effort to conduct research data management, to make it easier to be integrated into your everyday research. Because obviously there are multiple ways to address this problem, but when you look at the incentivation point of view, that's on the side of the professors and maybe also the funding organizations or the universities. I don't argue that this isn't a field worth investigating, but I focused more on the researcher side of view. So there are practical problems, and these are three which I identified here. So first of all, we have insufficient guidelines. We have different guidelines already affecting research data management. For example, from the DFG, there is a checklist for research data management. We have, on the other hand, for example, the university standards. I, in particular, looked at the RWTH guidelines, but also of all TU9 universities to have like a comparison. But I went very into detail with the RWTH guidelines, and these are very vague and not quite as a guideline, more like a general set of rules. It's quite hard to figure out what to do when following those guidelines. On the other hand, we have a lack of knowledge amongst researchers. So in our NFDI for Ing or NFDI bubble, most of us know what to do, how research data management should look like, and there are different ideas and concepts all around, and this is totally fine. But for researchers on the outside of NFDI, this might be quite challenging to figure out where to start, what tools to use, what tools even exist to support them. And I looked into this as well, because the researchers that were surveyed responded that way, that they lack quite a lot of knowledge to even begin with research data management. And then you have, from these two effects, the insufficient guidelines and the lack of knowledge, the need to research about what to even begin with when starting research data management. And this is some kind of inquiry you have to figure out and to perform. And this causes more effort. So additional to the activities to be carried out in research data management, like creating a DMP, you have the additional effort of inquiry, and this accumulates to an amount that might be a little bit distracting from your actual work. And this is not seen very well by many researchers. At least that was what 168 researchers said in a survey conducted in 2020, and a paper you can find on Ingrid as well about that. So this is the idea, and I looked at all those things and said these are the reasons for the low use of research data management in the engineering sciences, and in particular project-based research, because there are different ways of researching, and these different kinds, I figured that the biggest part of those in engineering sciences would be project-based research, like funded projects or even dissertations, which is also a project with a fixed time frame and a fixed budget and a fixed goal as well. So looking at these three corners of this problem triangle, you can think about different solutions at every corner, but this is to some extent already fulfilled. So for example, for the lack of knowledge, we have many different online courses. For example, even in NFDI for Ing, we have the education platform, which holds many different things you can go through in self-study. There are a multitude of online courses, may it be on video, may it be on some kind of PDFs, or even courses you can take within your university to foster RDM. But the problem is that this does not seem to solve the problem, so the search continues. And also with the guidelines, there are plenty, for example, the DFG checklist, guidelines that already exist, but they don't seem to fulfill the needs of the researchers. So continuing with that, I can summarize that this RDM is not widespread at the moment. There are insufficient guidelines and knowledge about research RDM amongst researchers, and the effort needed initially as well as in day-to-day research is too high, or at least is perceived as too high. So this brings me to my research question of my dissertation. What features of an RDM framework for research projects in the German engineering sciences can support researchers in their research data management? And this I've broken down into different sub-research questions. So I first did a requirements analysis, then I went into research accompanying RDM process, and I figured we need some kind of decision support within this process. And afterwards, we have a validation. These are right now only like small marks, small titles for the research questions because they are too long, but I will show them when we get to them. Firstly, I'd like to talk about my method or methodology I used for that. And this is the design science research methodology. And it's there are different ones, and the most commonly used one is the one by Hefner. I, however, decided to use the one by Al-Turki et al., which is like a roadmap for research data management, considering 60 different research articles about design science research. And I went through this process, and I'm quite far already, I would say. So many of the things have already been completed, and I'm currently in the evaluation of my design. But also I need to consider feedback loops and rethink some things. So this is still going on. I hope to finish my dissertation at the 25th of September, or at least there's the final date for submission. Then afterwards there are some other things happening still, but we get to that later on. So I went through this process and did a dissertation, and I would like to share this process with you in a little bit more generalized way than shown here, because that's the too complex way to talk about it. And for that, I have brought an agenda. So firstly, I gave you my motivation and the initial situation already. And next, I would like to talk about the state of the art, the results I have accumulated today, and the verification and validation process that is already started and ongoing. And afterwards, I'd like to reflect about some limitations and give you an outlook about what to expect further on. And you can find this little diagram you can see right now also in the top right corner of every slide, so you see where we are at. So for the state of the art, I went ahead and did a literature review, systematic one, following the PRISMA method by Page et al. And this is originating from medicine, but I figured this was quite good way because it's very thorough, and I wanted to use this approach to be sure that my state-of-the-art review is reliable. And I went ahead and screened like different repositories for literature, and also like the ones that are not quite listed as often or not listed everywhere, which are Ingrid and Ingrid preprints, Bausteine FDM, and Zenodo. Because these are, at least from my perceiving, the sources of exceptionally RDM focused contents, let's say. And I went ahead there because I figured that was something to consider, because this is where most of the RDM stuff is from, at least NFDI for Ing is published, and therefore I included this as well. And the total number of records I then had were 88 records from about, yeah, 2,350-ish. And there were many, many tools, many different concepts for research data management in there. And I compared these to also the idea I had in mind answering research questions for the literature review. So there are these questions which are listed on the left-hand side. So is the perceivance of researchers that there are insufficient research data management supports justified, or are there already frameworks satisfying the requirements of the researchers? And most importantly for me and my dissertation, is there a research gap? And what requirements can I derive from the tools that exist already, or not only the tools, but also the concepts? And there were many different, as I said, concepts and tools, many specialized tools for very specific jobs in research data management, some more generalized approaches. And today I just brought like 2 of them to give you an idea what the ones that are closest to my dissertation look like, and what I perceived were the, yeah, maybe the benefits, but also the downsides of these. So on the one hand, we have, for example, Heliport. And Heliport has a structure and a process within, which is like data lifecycle. And this data lifecycle has the common phases, but also like this iterative circle at the bottom right, you can see here, where you go through a mini cycle within the project cycle. And also the project cycle can make a shortcut to go in another loop of iterative trial and error, which is quite interesting to see that you can modify your experiment and change the setup and try again if your results are not what you expect them to be or what you need them to be. And this whole process is quite interesting and is for the Helmholtz centers, which is the place where Heliport originated from. And there are some pros and cons. So there is a clear process for all Helmholtz centers. And this shows also existing solutions within the Helmholtz center that are to be used by the researchers there. But it's not quite adaptable to other guidelines. So if you're not researching at Helmholtz centers, it's quite challenging to adapt this. This is to some extent possible, but it's quite hard. You cannot simply go ahead and select like a different idea or different fund giver, different university, but you're stuck with the Helmholtz centers. So this is like this whole first block with the insufficient guidelines. Then we have the lack of knowledge. So that's not quite as big as a problem with Heliport, because there is obviously quite a lot of knowledge you can gather by applying their process, but there is no like knowledge transfer plan. There are no trainings to be had within the process, which you will later see is kind of also my idea to implement in my process. And last but not least, we have additional expense or additional effort. So there are only pros with Heliport because it really structures your whole life cycle of the research project, and there's also like partial automation in it. So Heliport is quite good already. This is why I picked it here as an example. But still, Heliport lacks supporting aid that shows like the existing guidelines and also the applicability to different use cases than the Heliport Central, the Helmut Central. And therefore it is quite application oriented, but not as I would like to see it, and also not as the researchers which were surveyed and interviewed described it as they need it to be for them to be applicable in everyday research. So I went ahead and looked at different things, and there was a different one which was quite interesting also in the terms of the technical solution behind it. And this is an approach by Moskova at Chevala and many other ones. There are like 4 to 5 papers which came up in my literature review, a little bit different approaches to the same framework, but from different perspectives. And their idea is to create a research data management system with data management and knowledge management in it. So we have different view on the whole process, not from the process as researchers go through it, but from the data flow perspective. So we have like research objects and experimental results, which are then enriched with metadata and additional information that links them together, and then passed to the data management and the knowledge management base. And this forms the whole research data management system. And this also leads to some quite interesting pros and cons there. So it's a very clear concept for research data management. How the data flows through the whole process is very well explained and very properly defined. And also with the technical solution behind it, it's quite formulated. However, there are no guidelines considered at all, so we have the insufficient guidelines again. And it's also research data management from a research data management perspective, which many of the papers I found share. So when research data managers talk about research data management, it's often from a research data management perspective. And even if they consider the perspective of researchers by conducting surveys or interviews or workshops or whatever, it's often still from the idea, how can we make this data fair and what do researchers need to do for it? And I'm tripped a little bit about this thought, because it should be the other way around. So what do researchers need to make research data management and make their data fair? And this is what then further motivated also my dissertation, because I wanted to get into this perspective and design research data management from the perspective of researchers. And how this worked out, I will get to in just a few minutes. So to the other things of this concept I just introduced to you, as I said before, there is no knowledge transfer planned because it's like from the data side of view. But there is a lot of reduction of effort for research data management in there, because there is automation also planned or already implemented as well. And this whole review of literature will also soon be published if you have more interest in that topic, on paper in Ingrid, which I'm currently writing with also, as I see in some of you who are in the call already. So greetings to those. Then let's summarize the state of the art before I come to my proposed solution. We have the insufficient guidelines, which are quite a challenge for researchers as they bring additional research or inquiries with them that need to be conducted and are not quite solved by the conceptual frameworks that already exist. So what's additionally then to be considered is that some of the guidelines are a little bit contradictory. For example, the RWTH, if I may use this example one more time, demands, or not demands, but suggests that you use their RDMO instance. And for example, if you conduct a European research project within the Horizon Europe funding, then DMP Online would be your tool of choice. So the question then for researchers arises, which tool should I use? Should I go with the one that my university suggests, or do I need to follow the one my funding organization demands? And obviously, this whole clarification requires additional effort. Then the same goes with the lack of knowledge, that there are only limited practical relevances of some of the trainings you might find online if you go for a quick Google search, for example, or if you go for the education platforms that are already available in the internet. You might find trainings, or for example, for DMPs. And this training might be quite good to give you an idea of what to expect from DMP. But if you need training on a specific tool, you might not get what you desired. So if you consider, again, the NFDI for Ink trainings, there are plenty of trainings available for RDM and one for DMPs in specific, but these are focused on RDMO. And if you need to use DMP Online, you won't find a training for that there. So this is also a challenge, requires additional effort to seek those trainings out, and you obviously need to take those trainings, which is then additional effort once again. And the additional effort or the additional expense is still there. So this is quite the problem for researchers. I talked about that already. So copying data from one resource to another, looking up, for example, the right license for your liking and for the demands you see. So it's quite hard to get all this stuffed into your everyday research, which is already quite tightly scheduled. So we need a standardized process-oriented approach which supports the work for researchers and aids them within the guidelines they are forced to use in their specific research projects, and a more application-oriented and transparent manner than there is currently available, maybe also. And we need also a way to give those researchers the knowledge they need within the process at their very point of need. So, as I said, there will be a paper about that for those who are interested. So, considering all those challenges, I started researching on my first research questions. What requirements do researchers have when considering the German engineering sciences within research projects? And there were different steps I took to gather these requirements. Firstly, there was an exploratory survey with 168 respondents, and there are like some findings already from this. But there are like some gaps in the findings. So I got a good overview of where the problems might lie, but the idea what research data management should look like from the perspective of researchers what was quite unclear. So I went ahead and did some different approaches. Firstly, problem-centered interviews to get the idea what is the problem of researchers in research data management. And as it became clear that this was also related to the process of research data management, I went ahead and did a little bit further research in collaboration with also the LUH in Hannover. And there were workflow workshops which focused on the very workflow of researchers in their day-to-day research. Nothing to do with research data management in particular, but their research practices. And this led to requirements which were 8 requirements from the exploratory survey, 17 from the problem-centered interviews, and 28 from the workflow workshops, which are quite broken down into the different steps of research and how they follow up on each other and how they are related to iterative tasks and stuff like that. And there are some restrictions to that. Firstly, the requirements from the problem-centered interview are restricted by the small sample size of only 19 respondents there, and that the process was unspecified, which I tried to account for with the workshops. These also had a small sample size, and there is a bias on the RWTH and the LUH. So, if you are interested also in this, there are 2 papers actually focusing on these. And the survey paper is already published. The other one, matching the data lifecycle and research processes in engineering sciences, is still on the preprint server. And this directly led me to the answering of the second question, not quite directly, but it was the result of it. So the second research question I already answered is, can research data management be designed as a guided process in engineering research projects? And the answer is yes. But the question is how? And this went by the combination of the identified requirements, some community feedbacks. There were different talks held by me within the NFDI, with NFDI for ING, and also within the RDA and some other initiatives in Germany. And on the other hand, there was the literature I consulted. There are research processes. Here is, for example, one that is not a data lifecycle, but also data lifecycles, obviously, because they are so important for research data management. And combining all these with further RDM processes that are found in literature, I, together with a team, some of those are also here in this room, developed a process for research data management within research projects. And I would like to talk about a bit this process. So the process has 3 layers. And these layers can be used to represent different stages of the research. And obviously, you don't see any data life cycles in here. And you might think, okay, what is he proposing? This is unacceptable, but don't worry. If you bend the lowest part of it a little bit, just a little bit, then you get like these somewhat data life cycles from that. And within every data life cycle, you have in this project, from every iteration of data you create, you then have artifacts that are created. And these data sets, these are artifacts that are like little building blocks of your research. And these little building blocks you can combine to greater things. For example, to gray boxes, which represents findings. So if you have different artifacts, you can combine them to a finding, which is a bigger thing, a creation of knowledge, let's say. So if you record some data, with a script you programmed before. These are two artifacts you combine to get recorded data. And then you have another script, maybe some source code you've written to analyze this data, combine these two, and create a new analyzed data set. And if you look into this analyzed data set, you might see the finding you are looking for. And this is the new knowledge created. And from there on, you can structure the whole process based on these artifacts. And how do we come to those artifacts, you might wonder? Well, let's take me into the process, and I will do so by going through the levels from top to bottom. You have a little image at the left-hand side to not get lost in the process overall. So when a project starts, we usually have some kind of planning for the research project, which encompasses, for example, the writing of the proposal and also the adjustment of the proposal, and many different steps to gather consortia if needed to write and outline your general research idea. Some funding organizations demand sketches before they accept your proposal. And this all happens in the project planning phase. And there you also have some RDM tasks, like clarify your funding demands, what you need to do in terms of research data management to be funded. If you look at DFG, for example, that might be quite different from what the BMBF demands. And you should also already fill out your data management plan at that pointed date to document the idea you had initially with your research project you propose here, because if you leave the institute and someone else has to research on the project you acquired, they might struggle to understand what the initial idea was. So then we have the next step, the execution of the research project, but this only ever happens if the research project is accepted, if the proposal is accepted and you are allowed to start your research. That is only true in project-based research, and it might be transferable to other kinds, but looking at project-based research, we have a kind of quality gate, let's say, between the proposal being accepted and the starting of the whole research project. And obviously, within the execution, you execute your research projects, you write some publications, and you have like a project kickoff, ongoing project management, and stuff like that. And within this, you have the content-wise executions, which is that what researchers consider like the real research, nothing beyond that, no project management, which is like kind of overhead. And if you completed all of your tasks within your proposal or within the dissertation you're writing, if you have research question formulated, if you answered all of those, you go into the completion phase where you write your final report and ensure that the data you collected is reproducible, and do some other things, check for fairness of your data and archive your data. Within this execution phase, let's dive one level below that and see what lies beneath. Here we have the stage where we look at the work package level or the research question level. So you have like a work package or research question you would like to answer. And first you need to plan this finding you would like to accomplish. But obviously it's not quite as easy as that. Because sometimes you don't know what your finding will be, but you plan what you try to figure out. So you select what you like to figure out and you define needed sub-steps. And sometimes, if it's a very big research project, you might also be forced to create a sub-data management plan. Then you go ahead and create or reuse data this is already available for you. So after that, you compile all the artifacts I talked about earlier and get a new piece of knowledge, a new finding, let's say. And this happens when linking those artifacts. And this is also most often the point where researchers start to write manuscripts about their research. And when they have a new finding, they publish this. And if you would like to also publish the data that brought you this finding, you obviously need to figure out which data belongs to this finding. And if you are linking those artifacts together and following the path, you can very clearly see which of the artifacts were used to create this. On the lowest level, we have this plan, generate, and keep or delete and store process, where you have like basically the artifacts which are generated by the ways of the data lifecycle. So this is very on the experiment side of view, and not only like experiments in the old-fashioned way, like conducting something in a laboratory, but also, for example, conducting a survey or whatever, or also writing software, which is not quite an experiment, but you plan what you would like to create as a software piece, then program it, and then see if this data is valid or not. For example, if you have like recorded data from some machine, you would check if the sensor was connected. For example, if it's all zeros, you can just delete it. You don't validate the data if the data you collected is correct or not. This is something for the analyze phase. And then you store the data if the data is correct. And I told you before, if you bend this a little bit, you get those artifacts, which you can then combine to findings. And this leads to the whole process you can see in here. This has already been published and is currently being validated with all TU9 universities, and there will be a follow-up paper on the validation. And if you are interested in this, just search my name, for example, on Ingrid, and you will find it there. For the third research questions, I took a look at how decisions can be supported by taking project-specific factors into account. And I figured I need some more data to precisely formulate those requirements. So I need to have a deeper look at the state of the art as well, and I need to do some stakeholder analysis, because research data management is not only dependent on the researchers themselves, but also on funding organizations or scientific supporting personnel, which is quite important to the whole process, but often overlooked. So I need to do a stakeholder analysis, which is still to come. And then I would like to formulate influencing factors for RDM. And these have different sources and might overlap quite a lot, actually. And I would like to formulate these in a way that they can later on be filtered, for example. So I start with the idea that all influencing factors can be covered by, like, let's say, a policy, which might be some kind of, for example, XML file. The technical solution doesn't matter here, but like a list of requirements, which is always the same list, but might contain empty values, for example, if someone or some organization does not specify which, let's say again, DMP tool you should use, this field can just be empty. And you should also highlight the importance of every of these steps. So then I need to validate this hypothesis there, that all influencing factors can be covered by that. And I would like then to model existing guidelines after this policy I created for all TU9 universities. And then we can filter these lists to get only the currently required policy steps. Like, for example, if I have a quite long list of policies for data management plans again, then I can filter by my university and maybe by my funding organization, and I get only those tools recommended by those organizations. So I get down from maybe a list of 10, 15, whatever, down to a list of maybe 2. And this is the idea I would like to further chase there. I already did some validation where I come further into this, and this went ahead with the RWTH guideline for a very specific project, which also had own research data management policy, I would say, but it's like a collaboration form that they filled together. And considering this already worked out once, but I need to spread it further out, like to have a generalization of this idea. So my idea in the total, to answer my research question, would be that there is a solution available for that if we address all these with 5 things. Firstly, we have the process at the very bottom. Then we have the policy management, depending on which different requirements are influencing your project. You get the filtering of your decisions, which is then a decision support. And we transfer knowledge then within this process based on your decisions made. You get only trainings for your choosings. For example, if you had like the demand that you use GitLab instead of GitHub, then you only get trainings for GitLab. And obviously that was quite important to many of the researchers, is the partial automation. And I would like to verify this, and I already started with this. And for that, I built a demonstrator, which is Jarvis. And I will go into Jarvis a little bit more in detail at the next slide. But firstly, I would like to talk about the verification and validation. So firstly, there was a proof of concept study with a very specific use case. And this was already quite a good feedback I could collect there, that it already worked to the most, and there are some minor adjustments to be done. Also, the underlying process is now being validated by expert interviews, as I already told you, and I am planning to do further proof of concept studies, which are still planned but not conducted yet. Okay, I introduced Jarvis to you, and some of you would like to know about that, so I go just a few minutes talking about Jarvis. The idea of Jarvis is basically the whole framework I introduced to you, just compressed into a web tool. So as I told you, you will choose which are the boundary conditions for your research project. And then you get the recommender system, which gives you the idea which tools you can choose and which tools not to choose. Obviously, you have freedom of choice. You can still choose those tools which are not recommended if you prefer them by any reason, but Jarvis will only give you the idea what way to go. And this block here, the policy management within the process is already implemented within Jarvis, is Jarvis itself. Jarvis is an acronym for Joint Assistant for Research in Versatile Engineering Sciences, but no one can or wants to say that every time, so I condense it into Jarvis. And then on the other hand, you have the researchers who have now, if they use it, hopefully the idea how to conduct research data management, how it integrates into their everyday research. You have the research they do as fair by default. If you construct the artifacts as fair digital objects, this should be true and they should be linked to each other, ensured by Jarvis and its underlying structure. And you have the documentation, which is standardized, you have managed licenses and access, and you have reusable data at the end and an ensured understandability. This is basically just a quick summary of Jarvis. And I also took a look at back when we talk about the validation, which are the limitations of my framework and my overall process and my dissertation and Jarvis as a whole. So this all belongs together, so it's kind of the same. And I brought up, I don't go through everything in the detail, but I wanted to bring them up because it's quite important to think about those. And for every method I applied, there are different limitations and tries to counter them. So the most common problem amongst them was the small sample size, because it's quite hard to get researchers from every engineering science discipline or every university, and this is still true. For example, within the TU München, we're still searching for someone to validate the process of research data management that was proposed. So if any one of you does know someone who is a researcher at TU München, at TU Munich, please let me know, because we are still searching for one, as this is the last TU9 university that's missing for the validation. Yeah, I try to counter these problems, and to my best of knowledge and to the best of what's possible, I did so and will continue to do so. Also in my next steps, which are the refinement of the systematic literature review, which is like already done, but the formulation of the requirements is still not 100% on point, which is quite important, I figure, at some very minor parts which are not affecting the whole thing, but some very small parts are still need to be considered there, especially for the stakeholder analysis. So this is also a preparation for the sub-research question 3. And then obviously sub-research question 3 needs to be answered, and also the validation needs to be completed. And the whole thing needs to be written, which is already progressing quite good. And I hope to finish the document at the end of September of this year, and then afterwards the whole process of the dissertation or the doctoral process then starts with the examination at the end, which is my last slide, the time frame for that. If you are interested in the dissertation and would like to see it, you still have to wait a little bit longer, because the thing is not quite written, as I said before. I have now around 120 pages, and I aim for like 150, but obviously I need to cut it down on some ends. So quite a lot of work to do, but also quite a lot of time still for me to complete it. And I hope that you enjoyed this talk. If you would like to see the slides, this presentation is soon on Zenodo. Currently, I'm a little bit impaired with my hands, writing too much dissertation. But it will be uploaded hopefully in the next weeks. And also you can find this presentation on YouTube at a later point and date, as it will be recorded and will be uploaded later. So thanks a lot for your attention, and I give the word back to Cord.
Yeah, thank you very much, Tobias, for your presentation. And before we start the question discussion, I would like to apologize for skipping your introduction. Sorry for that. I would like to catch up on this so everybody knows where you come from. So Tobias completed both his bachelor's degree in mechanical engineering and his master's degree in development and design in Aachen. He has been working as a research assistant at the Chair of Intelligence in Quality Sensing since 2021. As part of his work and his dissertation, he has developed, and we've seen that. You have presented that. Thank you very much for this. And with that, we say goodbye to our viewers on YouTube, and I will stop the recording, and you are invited to ask your questions here on Zoom, either by raising your virtual hand, or you can also ask the questions in the chat here.
Yeah.